Artificial intelligence, or AI, is a branch of computer science focused on creating systems that can perform tasks requiring human intelligence. These tasks include learning, reasoning, problem-solving, perception, and understanding language. Unlike traditional programming, which relies on strict rules, AI enables machines to adapt, process information, and make decisions based on new inputs. Imagine a computer that can learn from experience, recognize patterns, and respond intelligently. This is the essence of AI. As we begin our journey, think about how AI is woven into the fabric of modern life, shaping the way we interact with technology every day. AI is a game changer because it multiplies human capability. It can process massive amounts of data in seconds, automate repetitive tasks, and solve complex problems that traditional computing can't handle. For example, AI helps predict climate change patterns and accelerates drug discovery. By freeing humans from mundane work, AI allows us to focus on creativity and strategy. Its ability to handle big data, automate boring tasks, and tackle intricate challenges makes it one of the most important technologies of our era. As we move forward, you'll see how AI is transforming industries and daily life. You might not realize it, but AI is everywhere in your daily routine. When you unlock your smartphone with FaceID, use predictive text, or ask Siri or Alexa for help, you're interacting with AI. Entertainment platforms like Netflix, TikTok, and Spotify use AI algorithms to recommend content tailored to your preferences. In finance, AI detects fraud and alerts you to suspicious transactions. Navigation apps like Google Maps use AI to predict traffic and reroute you in real time. These examples show how AI seamlessly integrates into our lives, making tasks easier and more efficient. AI comes in three main types, each representing a step in its evolution. First, there's narrow AI, which is what we have today, systems designed for specific tasks. Next is general AI, the holy grail of technology, where machines can perform any intellectual task a human can. Finally, super AI is the sci-fi future, where machines surpass human intelligence in every way. Visualize these types as steps on a ladder, each one more advanced and capable than the last. Understanding these horizons helps us see where AI is now and where it might go. Narrow AI, also known as weak AI, is the only type of AI that currently exists. It excels at performing a single specific task, often better than humans. For example, a chess-playing AI can defeat grandmasters, but it can't drive a car or write poetry. Its abilities are limited to its programmed scope, making it highly specialized but not versatile. This is the AI you encounter in most applications today, from voice assistants to recommendation engines. As we explore further, remember that narrow AI is powerful within its domain, but lacks broader intelligence. Artificial General Intelligence, or AGI, is a theoretical form of AI where machines can understand, learn, and apply knowledge across any intellectual task. Just like humans, an AGI could switch from writing software to composing music or understanding human emotions seamlessly. Unlike narrow AI, AGI would possess true versatility and adaptability. However, we haven't achieved AGI yet. It's still a goal for researchers and technologists. The idea of AGI sparks imagination about the future, where machines could match human intelligence in every way. Artificial superintelligence, or ASI, is the hypothetical next step after AGI. This is an AI that doesn't just match human intelligence, it surpasses it in creativity, social skills, and wisdom. Imagine a machine that could solve problems beyond human comprehension, invent new art forms, and offer insights we can't even imagine. This concept is often found in science fiction, like Jarvis from Iron Man or Skynet. Experts debate whether ASI is achievable, but it represents the ultimate frontier in AI development. Machine learning, or ML, is a subset of AI. Instead of programming strict rules, ML algorithms learn from data. For example, you feed thousands of pictures of cats and dogs to an ML algorithm, and it learns to tell them apart by recognizing patterns. ML is about teaching computers to learn from experience without explicit instructions. This approach allows machines to improve over time, adapting to new information and making smarter decisions. ML is the foundation for many AI applications, from image recognition to language translation. Think of AI as the grand vision, creating smart machines. Machine learning is the method we use to achieve that vision. All ML is AI, but not all AI is ML. Older AI systems relied on rigid human-written rules, while ML learns from data. This distinction is important. AI encompasses a wide range of technologies, but ML is the driving force behind most modern advancements. Understanding the relationship between AI and ML helps clarify how intelligent systems are built and why ML is so crucial. Deep learning is a specialized subset of machine learning. It uses structures called neural networks to process data, enabling advanced capabilities like self-driving cars, facial recognition, and large language models. Deep learning requires massive amounts of data and powerful computing resources. By mimicking the way the human brain works, deep learning can identify complex patterns and make sophisticated predictions. This technology powers many of the most impressive AI applications today, pushing the boundaries of what's possible. Artificial neural networks are inspired by the human brain. They consist of layers of interconnected nodes or artificial neurons. Data enters through the input layer, passes through hidden layers where features and patterns are extracted, and exits through the output layer with a prediction or decision. This layered approach allows neural networks to learn complex relationships in data, making them ideal for tasks like image recognition and language processing. Neural networks are the backbone of deep learning, enabling machines to achieve remarkable feats. AI system relies on three main pillars: data, algorithms, and infrastructure. Data is the fuel, images, text, and numbers that the AI learns from. Algorithms are the engine, mathematical rules that process the data. Infrastructure, like GPUs and TPUs, is the physical body that provides the computing power needed for AI to function. These components work together to create intelligent systems capable of learning and adapting. Understanding these basics is key to grasping how AI operates behind the scenes. If an algorithm is a recipe, the AI model is the finished cake. An AI model is a program trained on a dataset, ready to make predictions or decisions when given new data. For example, GPT-4 is a trained model that can generate text based on prompts. The model is the practical outcome of the training process, encapsulating learned patterns and knowledge. AI models are the tools we use to apply AI in real-world scenarios, from chatbots to medical diagnosis. Algorithm is a step-by-step set of mathematical instructions. In AI, algorithms guide computers in analyzing data, finding patterns, and updating models to get smarter. These instructions are the foundation of AI's ability to learn and adapt. By following algorithms, machines can process information efficiently and improve their performance over time. Understanding algorithms helps demystify how AI systems make decisions and evolve. Intelligent automation combines traditional automation with AI. While old automation systems could only perform repetitive tasks, intelligent automation adapts to changing situations. For example, a factory belt moves boxes, but an intelligent system uses cameras to detect damaged boxes and sorts them automatically. This fusion allows machines to handle more complex tasks, improving efficiency and reducing errors. Intelligent automation is transforming industries by making processes smarter and more responsive. Expert systems are early forms of AI that use databases of knowledge and if-then rules provided by human experts. They solve complex problems by asking questions and narrowing down possibilities. For example, a medical diagnosis program from the 1980s would ask a doctor a series of questions to identify a disease. While expert systems predate modern machine learning, they paved the way for more advanced AI by demonstrating how computers can mimic expert decision-making. Computer vision is the field of AI that enables computers to interpret and understand the visual world. By analyzing digital images from cameras and videos, AI models can identify, classify, and track objects. This technology powers self-driving cars, allowing them to see pedestrians and stop signs, and helps security systems recognize faces. Computer vision bridges the gap between human sight and machine perception, making it possible for computers to see and respond to their environment. Natural language processing, or NLP, is the ability of computers to understand, interpret, and generate human language. Human language is complex, full of slang, sarcasm, and context. NLP bridges the gap between human communication and computer code, enabling machines to read, write, and converse naturally. This technology powers chatbots, translation tools, and voice assistants, making interactions with computers more intuitive and human-like. Speech recognition is a branch of NLP that enables AI to translate spoken language into text. When you talk to your phone and it types out your message, or when YouTube generates captions for videos, that's speech recognition at work. This technology makes it possible for machines to understand and respond to spoken commands, enhancing accessibility and convenience in everyday life. Despite its impressive capabilities, AI has significant limitations. It lacks common sense and context, operating on statistical probabilities rather than true understanding. AI is only as good as the data it receives, which can introduce bias and fairness issues. Advanced AI systems often suffer from the black box problem, where their decision-making processes are opaque even to their creators. Generative AI models can confidently produce incorrect information, known as hallucinations. Additionally, AI requires enormous energy and resources, raising environmental concerns. Finally, AI cannot replicate genuine creativity or empathy, as it lacks lived human experience. One major limitation of AI is its lack of common sense and context. While AI can write essays or solve problems, it doesn't truly understand the world like a human does. It operates based on statistical probabilities, not real-world experience. This gap leads to bizarre errors when AI encounters situations outside its training. For example, an AI might confidently describe love but has never felt it. This limitation is a fundamental challenge in making AI more human-like. AI systems are only as unbiased as the data they are trained on. If an AI is fed data from a company that historically hired only men, it may learn to favor male candidates. AI doesn't correct human bias, it can magnify it unless carefully managed. Ensuring fairness and eliminating bias in AI is a critical challenge, especially as these systems are used in hiring, lending, and other sensitive areas. Advanced AI systems, especially those using deep learning, can become so complex that even their creators can't explain how decisions are made. This black box problem poses legal and ethical challenges. If an AI denies a loan or misdiagnoses a medical scan, tracing the logic behind its decision is often impossible. Transparency and explainability are crucial for building trust and accountability in AI. Generative AI models are known for hallucinating, producing information that sounds plausible but is factually incorrect. These models prioritize sounding correct over being correct, which can lead to misinformation. This limitation is especially problematic in fields like healthcare or finance, where accuracy is critical. Addressing hallucinations is an ongoing challenge for AI developers. Training and running modern AI models requires vast amounts of electricity and water for cooling data centers. As AI scales, its carbon footprint becomes a major environmental concern. Balancing technological advancement with sustainability is essential for the future of AI. Developers are exploring ways to make AI more energy efficient and environmentally friendly. AI can remix existing art, music, and text, but it cannot experience genuine emotional breakthroughs or invent entirely new paradigms. True creativity and empathy are rooted in human experience, which AI lacks. While AI can generate impressive outputs, it doesn't possess the depth of feeling or originality that defines human creativity. This limitation highlights the unique value of human insight in art and innovation. Smartphones are packed with AI features. FaceID uses AI to recognize your face, predictive text helps you type faster, and voice assistants like Siri and Alexa respond to your commands. These technologies make smartphones smarter and more user-friendly, demonstrating how AI enhances everyday convenience and security. Entertainment platforms like Netflix, TikTok, and Spotify use AI algorithms to recommend content based on your preferences. These systems analyze your viewing or listening habits to suggest shows, videos, or songs you'll enjoy. AI personalizes entertainment, making it more engaging and tailored to individual tastes. Banks and financial institutions use AI to detect fraud and alert customers to suspicious transactions. These systems analyze patterns in spending and identify anomalies that could indicate fraud. AI improves security and helps protect your money, making financial services safer and more reliable. Navigation apps like Google Maps use AI to predict traffic and reroute you in real time. These systems analyze data from millions of users to provide the fastest routes and avoid congestion. AI makes travel more efficient, saving time and reducing frustration on the road. AI is used to predict climate change patterns by analyzing vast amounts of environmental data. These models help scientists understand trends, forecast weather, and develop strategies to address climate challenges. AI's ability to process big data makes it a valuable tool in environmental research and policy. AI accelerates drug discovery by analyzing chemical and biological data to identify potential treatments for diseases. These systems can process information faster than humans, helping researchers find new medicines and therapies. AI is revolutionizing healthcare by making drug development more efficient and effective. Security systems use AI to recognize faces, detect unusual behavior, and monitor environments. These technologies enhance safety by providing real-time alerts and automating surveillance. AI makes security smarter and more proactive, protecting people and property. E-commerce platforms use AI to recommend products, personalize shopping experiences, and optimize pricing. These systems analyze customer behavior to suggest items and improve sales. AI makes online shopping more convenient and tailored to individual preferences. AI assists doctors in diagnosing diseases, analyzing medical images, and recommending treatments. These systems can process vast amounts of medical data, helping healthcare professionals make more accurate decisions. AI is transforming medicine by improving diagnostics and patient care. Educational platforms use AI to personalize learning, recommend resources, and assess student progress. These systems adapt to individual needs, making education more effective and engaging. AI is helping teachers and students achieve better outcomes by providing tailored support. AI powers self-driving cars, optimizes traffic flow, and improves logistics. These systems analyze data from sensors and cameras to make real-time decisions, enhancing safety and efficiency. AI is reshaping transportation by making travel smarter and more reliable. Marketing teams use AI to analyze customer data, predict trends, and optimize campaigns. These systems help businesses target the right audience and measure the effectiveness of their strategies. AI makes marketing more data-driven and impactful, leading to better results. AI enhances communication by powering chatbots, translation tools, and voice assistants. These technologies make it easier to connect across languages and platforms, improving accessibility and convenience. AI is making communication faster, more efficient, and more inclusive. Social media platforms use AI to filter content, detect spam, and recommend posts. These systems analyze user behavior to personalize feeds and enhance user experience. AI helps keep social media safe, relevant, and engaging for millions of users. Smart home devices use AI to automate tasks, control appliances, and enhance security. These systems learn your preferences and adapt to your routines, making home life more comfortable and efficient. AI is bringing intelligence to everyday living spaces. Retailers use AI to manage inventory, predict demand, and personalize customer experiences. These systems help businesses operate more efficiently and respond to market trends. AI is transforming retail by making shopping smarter and more responsive. AI helps farmers monitor crops, predict yields, and optimize resource use. These systems analyze environmental data to improve farming practices and increase productivity. AI is making agriculture more sustainable and efficient, supporting food security worldwide. Manufacturing industries use AI to automate production, detect defects, and optimize supply chains. These systems improve efficiency, reduce waste, and enhance quality control. AI is driving innovation in manufacturing, making factories smarter and more productive. As we look ahead, AI will continue to evolve and shape our world. From basic definitions to cutting-edge deep learning, we've explored the building blocks of AI and its limitations. The future holds exciting possibilities, but also challenges that require careful consideration. By understanding AI's fundamentals, we can better prepare for the innovations and ethical questions that lie ahead. Stay curious and keep exploring as AI transforms the way we live, work, and connect.